Hi everyone, welcome. The purpose of this video is to walk through this example that we saw in class on Wednesday, August 18th. The problem is asking us to find percent abundance when we already have relative atomic mass, which we abbreviate A little r. Whenever we start any problem, our first step should be to read it out loud. So let's go ahead and do that together. Rubidium has a relative atomic mass of 85.47 and consists of two naturally occurring isotopes. Rubidium 85, this U number just refers to the fact that when we say rubidium 85, and this 85 is a mass number, the reality is that the mass is just a teeny tiny bit smaller than that because we assume protons and neutrons have a mass of 1 AMU. The reality is that they're actually slightly smaller. For the purposes of this, what I'm really focused on is you conceptually understanding how to find percent abundance given relative atomic mass. So let's just go ahead and cross out the U's just for now, because what I want is for you to understand how this math is set up, and then we can add this idea on later. All right, so we're trying to calculate the percent composition of these isotopes. That's the same thing as saying percent abundance of these isotopes in a naturally occurring sample of rubidium. So let's remind ourselves, like, what does this even mean? What we're saying is if we have a naturally occurring sample of rubidium, if we have some sort of sample with a bunch of rubidium atoms, each of these is representing one atom of rubidium, the element rubidium. Oops. So lots of different rubidium atoms. Here we go, here we go. All right, so we know all of these atoms have the same number of protons. We can figure out how many protons a rubidium atom should have by going to the periodic table, which we have right here, and looking up rubidium. We see rubidium is number 37. All right. And so it should have 37 protons. So every single one of these atoms has 37 protons. That's what makes it rubidium. I'm not going to write this for every atom, but every one of these atoms has 37 protons. What's different is that there's a different number of neutrons. We see from this rubidium 85 and rubidium 87 that the mass number can either be 85 or 87. Mass comes from protons and neutrons. So that means the number of neutrons that I have can either be 85 minus 37 or 87 minus 37. And so the number of neutrons can either be, I'm not trusting myself to do mental math while making a video, 48. Of course, this is subtraction. We should be able to do, but on the spot making a video, I'd rather use my calculator. So the thing that differs between our different rubidium atoms is how many neutrons they have. It's possible for them to have either 48 neutrons or 50 neutrons, which would give us these two mass numbers of 85 and 87. So some of these atoms are going to have a mass number of 85 or weigh 85 AMUs. Some will weigh 87. And that just kind of randomly happens in nature. Our job is to find out what percentage of my atoms have a mass of 85 and what percentage of my atoms have a mass of 87. All right, so how am I going to set this up? Well, I'm going to use the formula that you learned in your extension, that relative atomic mass is equal to the sum of the percent abundance times the mass number for each isotope. All right, so relative abundance, they give us that 85.47 is equal to the percent abundance. That's what we're looking for our two isotopes. All right, so my isotope number 1 has a mass of 85. I wrote this kind of in a weird spot. Let me fix that. And then my second isotope has a mass of 87. All right, so now I need to find the percent abundance. What do we know? Well, we know, let's take a look at a new page here. We know that I have some number of rubidium atoms, and some of them have a mass of 85, and then rubidium 87, some have a mass of 87. I know that all together, these are the only two isotopes. So all together, this will be 100% of my sample, either 85 or 87. So I'm going to call the percentage of atoms that have a mass of 85, I'm just going to call that X. I put percent abundance here. You can absolutely do percent and then divide by everything by 100, or you can also just do abundance in decimal form. I'm kind of assuming we're pretty comfortable converting between percents and decimals. If not, something to tag me about in a document, something to chat about. All right, so if my rubidium atoms, if the percentage of my total that's rubidium is X, and we know in total 100% of the atoms are either rubidium 85 or rubidium 87, that means that rubidium 87, the percent abundance is 100% minus X percent. If I want to do that in decimals, because to me it's just easier to put things in decimals for this formula, that would be 1 minus X. So my 2% abundances for my two isotopes are X and 1 minus X. Everything left over when you subtract out X. Could I have done here 1 minus X and X? Absolutely. Either way. You just need to keep track of what you defined as X. All right, so now this just becomes an algebra problem. So let me grab a new page so I have space to do the algebra. I know sometimes this is where people are either feeling really good or people get a little overwhelmed. But we're just solving for a single variable, just like you would do in math class. 85x plus, I'm going to distribute this 87. So I'll get plus 87 minus 87x. 85.47 equals, I'm just going to combine like terms. In this case, I have 85x, 87x, so negative 2x plus 87. Now I'm going to subtract 87 from both sides. 85.47 minus 87, negative 1.53 equals negative 2x. Great. And now I just want to get x by itself, so I'll divide both sides by negative 2. And x is equal to, divided by 2, is 0.765. And that means this is the abundance for my rubidium 85. Remember, that's what we defined as X. And so to find my abundance for rubidium 87, I just need to do 1 minus. Everything that's not rubidium 85 is rubidium 87. So 1 minus 0.765, 1 minus 1 minus 0.765, I get 0.235. Just going to convert these to percents. So my percent abundance for rubidium 85 is 76.5%, which I'm getting from right here, just making that into a percent. And for rubidium 87 is 23.5%, which I got from right here. I just made that into a percent. All right. I hope that helps. Remember, you can use a question document. You can tag me. You can send me an email. Make sure you're getting any questions you have answered before you come to next class. Make sure you're ready for class by going over this, making sure you understand. The only other thing I want to mention is if we had not crossed out these U's here, the only thing that would change is this mass number was kind of an estimate. We would just put the exact mass. So instead of 85, 84.91, and instead of 87, 86.91. That's another step that once you get familiar with this formula won't feel like an extra thing. So focus on conceptually understanding where I got x, where I got 1 minus x, how I did this math, and then you can add in this layer of the u. All right, I'm here to help if you have more questions. Again, here's our final answer. Thanks for watching.